Good morning. Today we'll continue with solving systems of equations using the Gaussian elimination. I have three examples. One of them will involve a situation where there is no solution. One will involve a system that has an infinite number of solutions, and one involves a system involving trigonometric functions as coefficients of the variables in the system. Just keep in mind the algorithm is what is important. Once you learn that algorithm, the process to solve these, to reduce to row echelon form, no matter how difficult the system, just follow that process. And the problems can be tedious. Be careful for your arithmetic. Don't work too quickly. That causes careless mistakes. So here we're going to begin by transforming this first column into coefficients of 1, 0, and 0. I already have the 1 in place in my first equation, so that's great. That means as far as the first iteration, that step is complete. So I can then write that equation here to represent my first iteration. And now I want to use that equation to multiply it by whatever's necessary to convert the coefficients under it to zeros. So the first thing I will do then is take this row and multiply it by -2 because I'm trying to change the 2 to a 0. So multiplying this row by -2 will give me opposite coefficients on the x's. Be so careful. Make sure that you multiply each number by the -2. And then under that, I'm going to copy down row 2. And once I add those together, I should have an equation that has a coefficient of 0 on the x. So I can then write that as my new second row in the first iteration. Next, I need to change the 5 to a 0. So this time, I'll multiply my row 1. This thing doesn't want to cooperate today. Multiply my row 1 by a -5. So that gives me -5x plus 55y minus 20z is equal to -15. Under that, I want to write down my row 3. And once I add those two together, I should get a row with a coefficient of 0 on the x. And that is my row 3 for my first iteration. So I have a coefficient of 1 on the x. I have no x's under it, no x's under it. Now I move over to column 2. And in column 2, I want to change my 26y to a 1y and my 52y to a 0y. My first row is complete. So I can go ahead and write down my first row. And I need to focus on the 26y. I need to change that to a 1y. Well, to change a number to 1, we divide by that number. So my row 2, I'm going to divide by 26, and that will give me 1y minus 9/26 z equals 1/26, and that becomes my new row 2 in the second iteration. That's the row that I will use to convert the coefficient of y under it to a 0. So to change 52 to a 0, I need to multiply my new second row by negative 52. Notice we're not using calculators here. I'm telling you, calculators will get you in trouble. If you depend on them in doing your assignments, you won't have the practice you need in doing them when you're not allowed to use them. So I'm multiplying negative 52 by my new second row. And under that, I want to copy down my third row. And when I add those together, my y coefficient should be 0. And it is. But my z's also eliminate. Negative 2 and negative 12 is negative 14. So my new third row, 0 equals negative 14, is obviously a false statement. That indicates that this system has no solution. An equation involving 3 variables represents a plane. So what this means is these 3 planes that we started with do not have a common point. The next example I have doesn't involve trigonometric functions because you know the definition of a linear equation is that there are no trigonometric functions. But the coefficients of the variables x and y are trigonometric functions of theta. They are simply constants once we know what theta is. So this is a linear system. To transform it into row echelon form, my first iteration, I need to have a coefficient of 1 on the x. So to change cosine of theta x to 1x, I need to divide that entire row by cosine of theta. That will give me 1x plus sine of theta divided by cosine of theta times y is equal to 1 divided by cosine of theta. I simply divided each term of that first equation by cosine of theta. So that becomes my new top row in the first iteration. Incidentally, you may want to change sine over cosine to tangent and 1 over cosine to secant. I found it easier just to stick with sines and cosines, but that's certainly your choice. To complete the first iteration, what I now need to do is change the negative sine of theta x to 0x. What that means is I need to take my new row 1 and multiply it by sine of theta, which is the opposite of negative sine of theta. So when I multiply my new row 1 by sine of theta, I will have sine of theta times x plus sine squared of theta over cosine of theta times y is equal to sine of theta over cosine of theta. So the purpose of doing that was then to add my bottom row to that, thus eliminating the x term, or representing the x term with a coefficient of 0. So I copy down my second row under that, and now I'm ready to add those two together to get my new second row. So these terms are opposites, they add up to 0. And then what I'm left with are two y terms to combine whose coefficients aren't like terms. So what I do is just add those coefficients together, or write down the indicated addition. And that sum is the coefficient of y. And on the right-hand side, when I add together, I get sine of theta over cosine of theta. So that is my new second row, where I have a 0 coefficient of x, and I have a coefficient of y. Moving on to the second iteration, my next step would be to change the coefficient of y in the second row to a 1. Well, to achieve 1s, we divide by that coefficient. Let's go back. If you recall here, when I was trying to go to my second iteration to change that 26y to a 1y, I divided the row by 26. So that's what I need to do here. I need to divide this row by this. Well, that's kind of messy. So I think it would be helpful to simplify that first. Simplify. Shouldn't be too hard to do because we can add these together, getting a common denominator, changing the second term to cosine squared of theta over cosine of theta. Now I have a common denominator, so I can add the numerators. And what do you know? That numerator, sine squared of theta plus cosine squared of theta, is 1. So that coefficient of y is simply 1 over cosine of theta. So I'm going to take a second to rewrite my second iteration with that simplified version of the coefficient of y. So I have 1 over cosine of theta y equals sine of theta over cosine of theta. That's just this iteration in simplest form. Okay, so again, to move to the third iteration, I want to change the 1 over cosine theta to a 1. Again, to achieve 1s, we divide by the coefficient. So if I divide by 1 over cosine theta, that is equivalent to multiplying by cosine of theta. Divide by 1 over cosine theta. That's how I'm going to change that to a 1. Well, first of all, my first row is done. I'm just copying it over again. And now to get my new second row with a coefficient of 1 on the y, I'm dividing each term by 1 over cosine of theta. So I have 1 over cosine of theta divided by itself gives me 1y. And on the other side, sine of theta over cosine of theta divided by 1 over cosine of theta, which means multiply by the reciprocal gives me sine of theta. So my new second row, y equals sine of theta. So now I actually know the solution for y. To finish solving this system, I only need to figure out what x is. To find x, I take my first equation and replace the y with what it's equal to, thereby solving for x. So I will have x plus sine of theta over cosine of theta times y, which is sine of theta, is equal to 1 over cosine of theta. Or x plus sine squared of theta over cosine of theta is equal to 1 over cosine of theta. To get x by itself, I want to subtract sine squared of theta over cosine of theta from each side. Since I have a common denominator, I can go ahead and subtract the numerators. And then, recalling an identity, that 1 minus sine squared of theta is equal to cosine squared of theta, I can make that substitution. And once I reduce, I find that x is equal to cosine of theta. So now I have the solution to the system. X is equal to cosine of theta, and y is equal to sine of theta. That problem is challenging with the trig, but the algorithm of transforming the system into row echelon form is what's essential. Focus on that algorithm. Let's look at one more. No trig in this one. My approach: I focus on the first column. I want to change that column to a coefficient of 1 on the x and zeros under it. There is no advantage to rearranging the system because none of the equations have a coefficient of x. So I'm going to go with it as it is. Therefore, in order to change this to a 1x, I need to divide that entire row by 5. So dividing by 5 gives me 1x plus 1y minus z divided by 5 is equal to 0. Now my next step to complete my first iteration is to change the 10x to a 0x. Using the row that I just created, I multiply that row by the opposite of 10, and then I will add row 2 to it to eliminate the x term. So my new second row becomes negative 5y plus 4z is equal to 0. Then, to complete my first iteration, I need to change the bottom row, 5x, to a 0x. I go back to my row 1, this time multiplying it by negative 5. Copy over row 3 under it. And that will then create my new row 3. And it's not necessary to write these zeros here. I was just doing it to remind you of the focus. So I've completed the first iteration. In the second iteration, I have I move over to column 2, and I want the coefficient of the y term in row 2 to be a 1. To get 1s, we divide. So I need to divide that row by -5. Now my first row is complete. I can go ahead and write that first row. Of the second iteration. So now dividing row 2 by -5, -5y divided by -5, 4z divided by -5, and 0 divided by -5. That gives me my new row 2. The last step in the second iteration is to get a 0 coefficient on the y in that third row. So to change 10y to 0y, I take my row 2 that I just got and multiply it by the opposite of 10. So I'll have -10y plus 8z is equal to 0. Now I copy row 3 under it, and I add those together. The y does give me a 0 coefficient, but I also lose the z term. However, this time I have a true statement. This indicates an infinite number of solutions. So how do we state our answer? What we do is start with the last variable, which is z, and we let z equal t. Well, if z is equal to t, then we can say that y minus 4/5 times t is equal to 0, replacing the z with the t, or that y is equal to 4/5 t. So we know z, we know y, now we need to find x. So if we go back to that first equation, where we know that, let me just write it down again, x plus y minus z divided by 5 is equal to 0. If I replace y with 4/5 t, and I replace z with t, I can combine those terms. 4/5 t minus 1/5 t is 3/5 t. And then I can solve for x in terms of t. So my solution is that x is equal to -3/5 t, y is equal to 4/5 t, and z is equal to t. To find a particular solution, you would simply need to choose something for t. For example, if I suppose that t is equal to 5, x would be -3/5 times 5, y would be 4/5 times 5, and z would be 5. we can choose anything for t. That's why we say there's an infinite number of solutions. So our solution in terms of t, and then if you are asked to give a specific solution, you may be given some value for t to use. It may be left up to you to pick your t. Pick anything you want to give your answer in terms of that choice. I cannot impress upon you the importance of showing your work. It is very difficult to track down a mistake in these problems if you were to make one. You know, if I'm checking your work, if you don't show your work, I'm not even going to look at it. I'm so sorry. It's just impossible. In fact, many times the only way I can find your mistake is to work through it following your work, and then where I see a mistake, I just start clean from there. It's to try to read through and find a mistake it's difficult. So please show your work. I don't think it's elementary to draw the arrows and tell what you're doing with what you're doing it to. I think it's very helpful to you as well as the reader to understand what's going on. So focus on the algorithm. This is what we'll be doing basically throughout this course, and so it's important to get a good understanding of it initially. Thank you.